I welcome you all for NikerCon 2024. I am Dr. R. Kishore Khanna from Department of Biomedical Engineering from Vailtech Rangarajan, Dr. Shakuntala R&D Institute, Science and Technology, Chennai, India. I am here to be associated with NigerCon for presenting my research article titled Innovative Cognitive Stroke Detection Analysis Using Deep Learning Methodology. So this is going to be the flow of the presentation. It's going to have abstract, introduction, literature survey, methodology, deep learning approach for detection and analysis process, which is going to provide a output that's going to be the results and discussion of the result with the conclusion and ending with the references. Abstract stroke is going to be the reason, one of reason where it leads to the death, and it is being most rapidly occurring neurological disorder, first point. And second point, it may provide a death within 12 to 24 hours. This stroke has been happening due to intracranial or seizure detection, and this is going to be a common one for occurrence of stroke. Recently, people are using artificial intelligence application inside the medical imaging concepts. So CT imaging or CT images is being employed for primary method, which is been determining the occurrence of stroke, that's going to be ischemia or hemorrhage, and AI has the ability or potential to find whether it's going to provide the stroke, whether it's going to be occurrence of stroke to be true or false with the data which is being initiated as a given input. So this study is to evaluate the stroke diagnosis that going to be compiled with the CT images. That's going to be non-contact CT images and CT images which has been associated with n number of datas where a stroke brain window is being analyzed as a main focus, which is being taken from online as well as public DBMS, that can be the database management system. And a sample size which is being trained for the given system, it's going to be 186 images, and this 186 images has been having a accuracy level plus or minus 7 percentage, where confidence levels is around 90 to 95 percentage. ResNet 18 is being employed as the modeling, where deep learning concept is being interfaced for finding the hemorrhage and its characteristics. AI model is being trained well with the pre-training and post-training process, where a test data set is being processed separately and training data set is being processed separately. So testing will be ranging from for 30 percentage, training will be ranging for 70 percentage for providing the highest accuracy with lowest data loss. So 186 images which is being taken is being employed, where 155 images is being detected with positive ICH positive, and 31 is being considered as a normal image, that's going to be the negative. So abnormality, that's going to be the positive, and the normality, it's going to be the negative. So deep learning model of this proposed research is been attaining 86 percentage overall accuracy for detection of intracranial hemorrhage, which leads to the stroke for the individual. So there are multiple types inside the ICH, that's going to be intracranial hemorrhage. Even all kind of types can be achieved by using this AI modeling, where a clinician and physician may assess the work and confirm the treatment or therapy to be provided in the golden hours. Introduction. Stroke is a neurological disorder which has been happening due to the assault leaded by the cerebral, and this will be blocking the flow of the blood or rupture the flow of the blood in the artery part of the brain. Nowadays, coronary artery disease is going to be a vital thing, or not going to be a rare condition due to the stress, due to the lifestyle changes, due to the mortality, cause of mortality, occurrence of coronary artery disease being widely seen, and this makes stroke to be occurring in 5 seconds. So occurrence of stroke is being classified into three types. One first thing is going to be ischemia, second one is going to be hemorrhage, and third one is going to be TR stroke. That's going to be a mini stroke elaborated as transient ischemia attack. 186 images is being employed, in that 155 is being considered to be a positive, so majority is being considered to be a positive, where sensitivity will be higher, specificity will be higher, and error will be lower. Error was being achieved for 14.1 percentage, that has been playing vital role for accuracy of 86 percentage. So proposed method has been finding the ICH condition correctly without any error, whether it's going to have multiple subtypes like IVH or SDH or SH abnormalities been detected, and accuracy is being 86 percentage, which is going to give a clear process when it has been compared with CT image means. So it's going to be a radiological analyst. So radiological physician, radiological analyst will be getting the assessment process by this work, and clinical setting can be employed. This clinical setting can be employed in any kind of AI solution which is going for detection or prediction process with the highest accuracy. And literature survey, usually people will be going with the existing system also employed multiple classifier. Now classifier has been employed, multiple windows has been employed, hybrid innovative research has been employed. Even though we are coming with uh, this stroke detector, where it can be predicting the data, predicting the sequence earlier with highest accuracy of 86 percentage, where we have to be concerned for the data loss of 14 percentage. So it not only for CT, it can be employed for MRI. When it has been turned into a biosignal application, same approach can be employed for the ECG signal or EEG signal. EEG signal can be employed, or ECG signal can be employed, cardiac imaging can be employed, neural imaging can be employed. So employing AI with different parameters, with different approaches, will be leading to the enhancement of accuracy. So how much amount of training is being given to the system or model will be leading or resulting in the accuracy and reliability of the outcome or output of the sequence which is being developed. So methodology, as we discussed, we are dealing with CT images. CT images is being extracted, modulated, evaluated by the CNN. 186 images is there. In that 150 is going to be the abnormal rate. We already told we are having the confidence of a 95 percentage. That's going to be plus or minus 7 percentage, and this data is being extracted from the Kaggle product, where the classification of model is being interfaced with the Kaggle product, where the parameters like age, gender, and employment are being taken as a parameter for providing a classification, and brain CT is being taken as the input, and it is being employed and trained for the system has been trained with all 186 images. In that 70 percentage it's going to be the specificity, and test data it's going to be 30 percentage. 70 and 30 will be resulting with a good employment. In this employment of modeling, ResNet has been employed, which will be classifying the cerebral hemorrhage and its characteristic when it is being detected. So most prominently, 224 pixel data will be initiated for for uh, for giving a input image, and this deep learning model will be employed processing each image with the feature classification, feature extraction, which will be processing from higher order sequence to lower order sequence. Each rows and columns will be examined with the interconnectivity networks, then it will be providing the output by using the softmax scaling process. So this is going to be the block diagram, functional block diagram, where input CT image will be taken. All images is being composed with pixel in rows and columns, and it will be given for the pre-processing, where feature extraction, all kind of alteration, minor alteration will be there, where segments will be separated, rows and columns will be separated, and once it is being pre-processed by the feature extraction, it will be given for the CNN for the training purposes. CNN is being employed with ResNet, which is been processing the data with higher order sequence to lower order sequence, where decision making will be done by the softmaxing layer. Activation function will be there, where zeros will be converted into one, one will be converted into zero, and it will be giving the processed data to the prediction, that's the decision layer. So decision layer will be detecting or predicting whether it's going to be normal. If it is abnormal, which classification abnormality is being predicted will be there, and it will be given the output as the uh, with all kind of classification with accuracy, data loss, error, specificity, sensitivity, and precision. So this is the process where cognitive domain is being employed with DL, and for providing the highest accuracy with lowest loss. So this is going to be the output where the analysis part has been taken, selected image is being taken, and it has been processed with the feature extraction where histogram equalization will be employed before the process, and filtering process will be there where unwanted data in the image will be removed. Then it will be trained by the CNN will be focusing only on the output of the sequence. Result, as we told, it is getting 86.2 percentage of sensitivity, 97.1% of specificity, and error has been around 14.1 percentage, which gives accuracy of 88 percentage. So 88 percentage with the 186 images, in that 150 images is going to be the abnormal data. By training with 186 images itself, we have achieved a model which is providing accuracy of 88 percentage. So this is the tabulation where clearly mentioned for each category of the abnormality with standard deviation plus and minus. So as we told, employing CNN, that's going to the deep learning model, uh, which has been employed, co- which is which has been considered as mannerism